Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking about the number of zeros at the end of n factorial. Quick review here, right? Remember that n factorial is a shorthand way of writing down the product of a bunch of numbers. So n factorial is n times n minus 1, n minus 2, all the way down to 1. This is for integers n, right? Whole numbers, positive numbers is what we calculate this for typically. Quick example, 5 factorial, right? 5 times 4 times 3 times 2 times 1. This is 120. These numbers get big pretty quickly. So 25 factorial is already this very, very big number, right? So we have this huge number here written out just for 25 factorial. Now, in terms of what we're talking about in this video, the number of zeros, right? We see in 120, 5 factorial, there's 1 0 at the end, whereas 25 factorial has 6 zeros at the end there. So this is what we're going to explore in a little bit more detail in the rest of the video today. So let's look at both of these two numbers quickly. We know the answers, of course. We know that 5 factorial ends in 1 0. But let's see if we can kind of understand where that 1 0 comes from in this case. So 5 factorial, 5 times 4 times 3 times 2 times 1. Of course, that times 1 doesn't really matter anyway. And let's look at the 5 and the 2. Why are we looking at the 5 and the 2 here? Well, 10, which is, right, 1 0, right? Anytime you multiply a number by 10, you're adding a 0 to the end of the number. So what we can do here is rewrite this as 5 times 2, so this is a 10, and then we have the times 4 times 3, times 12. And so this gives us our 120. But more importantly for the number of zeros, as soon as we see that 10, as long as we kind of extract all the powers of 10, we will know how many zeros show up at the end of the factorial. So that's kind of our key strategy here. So the 2 and the 5 go together to make the 10 in this case. We actually have more 2's, right? 4, is 2 times 2. So we could have put one of those 2's together with the 5 as well, right? No matter what, that's kind of going to be okay. We have 1 5 though, and so we put that with one of the 2's, and that gives us our 0. Now, we're not going to calculate this big number, and I'm not going to kind of write it all out there as well. But notice here that we're going to focus on the 5's we're looking for. So inside of this number, right, we have this is, right, 25 times ... times 20 times ... times 15, right, times ... there. So if we think about what powers of 5 we have, right, where do we have 5's? Well, we have a 5 in 5, and in 10, and in 15, and in 20, and in 25. So we have these 5 5's, multiples of 5's, in this 25 factorial when we're multiplying it all out. Now, here's where things maybe get a little bit confusing, and you should check this. Notice that we have way more 2's, right? Again, we're going to be pairing up 5's with 2's, right? So we can pair this 5 up, the first 5 up, with a 2, maybe the 2 itself, and this will give us a 10 there, right? This will give us 1 0. And this kind of strategy can go and continue. Notice 10 itself is 5 times 2, so that gives us, of course, a 10 here. We can pair up the 15 with a 2, and that will give us a 10. right? That will give us, again, each of these will give us plus 1, 0 in this case there. 20 itself has a 10, or has a 10 in it already. Now 25 will give us a 10 as well. And so now we might say, okay, we have plus 1, plus 1, plus 1, plus 1, plus 1. We have 5 zeros. But we need to be a little bit careful here. Because what is the number 25? The number 25 is actually 5 squared. So we actually get 2 5s, right? 25 is 5 times 5. And so we're going to actually get 2 of those 10s from pairing up with 5s in that case. So we actually here get 6 zeros, which is exactly what we expected. That was exactly our answer from earlier. And the key thing is we're counting the 5s. We're getting zeros for every 5 that shows up in multiplying out the factorial there. Really from every 2 and 5 pair, but right, we have 2, 4 already gives us 2, 6, 8 gives us 3, right? We have a bunch of 2s. So there's plenty of 2s to go around, and pairing them up with the 5s gives us all of our zeros in that case. So we're hopefully starting to see a pattern here. And let's try to do this with a number that we kind of, at least normally speaking, have no chance of calculating, right? So how many zeros are at the end of 300 factorial, right? You can calculate this probably not even on your calculator because it will give you scientific notation. If you do this on the computer, right, you can see that this number has 615 digits. You can find out the answer, but let's see if we can use our strategy for counting the zeros by counting the number of 5s, right? So if we look at all of the 5s, right, so we start with our 5s in this case. So we have all of those multiples of 5s like we did before. Let's not worry about the 25 for the moment. We have the number 5, we have the number 10, right? We have 15, 20, 25, right? And this is going to go all the way up to 300, right? 300 is a multiple of 5. And because 300 is, right, divisible by 5, 300 divided by 5 is 60, we can see that there are 60 5s in this case. And this will give us 60 zeros looking at just all the multiples of 5 here. So 5 has a 5, 10 has a 5, 15 has a 5, 20 has a 5, 25 has at least one 5, right? We're counting kind of 1 5 for each of these, and every one of those 5 will give us 1 0 when we match it up with a 2. Now, we did just say in the previous problem, we have to be worried about, well, what about numbers like 25? What about 5 squares, right? So 5 squares are numbers like 25. So we already counted 1 5 from 25, but there's a second 5, at least a second 5. 50 will give us another extra 5. 75 will give us another extra 5. Again, 300 is a multiple of 25. 300 divided by 25 is 12. So this will give us an additional 12 zeros. So let me write this as kind of plus 12 zeros in this case, because these are additional ones, right? We already counted 25 once, but we need to count it a second time because it actually has those double powers of 5 in it. Now, this pattern, however, doesn't stop here. What about 5 cubed? And kind of in general, you just need to keep doing this until you run out of, or until the numbers get too big. So how many 5 cubes do we have? Well, 5 cubed is 125. Then doubling that is 250. So we've already counted the fact that 125 is a multiple of 25. But now, because it's a cubed, we have a third 5. So in fact, this will give us plus 2 additional zeros. So we now have every power of 3 will give us 1 extra 0 there. Every third power of 5 in this case. Now, 5 to the 4th power is too big. So this is where we stop. But in general, you keep going up. How many 5s do you have? How many 25s? How many 125s? How many 625s? Etc. Now we have 60 zeros from the 5s, an additional 12 because we're counting powers of 5 squared or 5 squared multiples, and then we have an additional 2. So we have 74 zeros in total. So this is our total number of zeros when the calculation is complete. And again, this is something that you probably couldn't do just by saying, why don't you calculate 300 factorial? As I mentioned, it's a huge number that's not going to be very nice to deal with. So that's why this trick can be helpful. We can still learn something about how many zeros are at the end of this number from there. So this is really a good question, learning a little bit more about number theory. Right? We're thinking about powers of 5, multiples. We're doing a little bit of counting and probability for kind of saying how many are there. But really we're learning about the factors of a number, the multiples, and this is a great topic to learn more about in number theory. So if you're interested in this at all, I invite you to join our online math summer camp. It's running this July, and number theory is going to be the focus of the final week of that summer camp. So this is open to middle school and high school students, all different levels. So you can join, we'll learn more about you and make sure you're in the right group to learn a lot and have a lot of fun this summer. Thank you guys for watching. We'll be back next Thursday with our next tidbit. And if you can't wait, check out the ziml.areteem.org site and join the Zoom International Math League for free practice and other resources. Hopefully you liked this video. If you did, please like and subscribe below. And I will see you guys next time. Goodbye.